I think we'll go ahead and get started. I have a couple of minutes after 5. So again, welcome to the second public workshop for Johnson Meadow Restoration Planning. My name is Nora DeCure. I'm helping to facilitate this evening. I want to welcome you all and let you know that we are recording this webinar just like the last one so that it can be posted to the project webpage. We are using a webinar format tonight, Zoom webinar, so you may be familiar with that. It does mean that everyone is muted during the webinar. We will be using that Q&A function, and you'll see that in your Zoom control bar, usually at the bottom of your screen. And Tracy, if we could go to the next slide. Thanks so much. So note that we will be getting to that Q&A a little bit later in our evening. You are welcome, if you have questions, to be typing them into the Q&A box, just knowing that our presenters, as they're going through the presentation, will do their best to address them as they go through, but we may need to wait until that Q&A time in our meeting to really thoroughly get to them. So thanks for your patience there, but don't hesitate to chime in as you're thinking of things. And while that button does say Q&A as a function of Zoom, you are welcome to enter a comment as well. Though as I am managing the queue for the Q&A, I will try to prioritize questions that we have there tonight. If we could go to the next slide, please. If you are experiencing technical difficulties during the meeting, you are welcome to contact our team via text at that number right there on the screen, 916-882-9112, or you're welcome to let us know via the Q&A box, and our webinar producer will respond to you as soon as they're able. And we don't really have too many ground rules for our time together this evening, but please be respectful and civil as you do enter your comments and questions into the Q&A box. All right, let's go to the next slide. I'll just give you a quick overview of the agenda. So for those of you new to the project, we will take a few minutes to review the project background, why restoration is needed, the project objectives, and the schedule. We'll then talk about 3 restoration alternatives and how they compare to one another. We will take questions and comments as we just talked about, and then we'll wrap up with some next steps. And so finally, I'd like to ask a few folks to join me on screen so that I can introduce them. So we have Andrew Scher, who's our Restoration Program Manager and Project Manager from Tahoe Resource Conservation District, or what you might hear us say Tahoe RCD. We have Adam Lewandowski from Ascent Environmental, who is our Consultant Team Project Manager. And we're also joined tonight by Brent Wolf and Toby Haynes from Northwest Hydrologic Consultants, or NHC, and they will be sharing the overview of the alternatives with you this evening. So with that, I think it's time to go ahead and dive into the content. And Andrew, if I could ask you to do that.
Thank you very much, Nora. As Nora mentioned, I am the Restoration Program Manager with the Tahoe Resource Conservation District, or Tahoe RCD. And I'm the Project Manager for the RCD for the Johnson Meadow Restoration Project. So if we could jump to the next slide, please. As most of you probably know, Johnson Meadow is about a 206-acre meadow property located just south of Highway 50, kind of behind Grocery Outlet, and just north of the airport in South Lake Tahoe. It encompasses what's known as reaches 1 and 2 of the Upper Truckee River, and it's home to significant wet meadow environments, significant habitat, and since it was purchased by the RCD in 2018, it is valuable public open space. The public ownership of the Johnson Meadow property makes a comprehensive restoration effort along the Upper Truckee River corridor possible. Essentially, almost the entirety of the lower 9 miles of the watershed are now in public ownership that join the upper portions of the watershed, which are managed by the U.S. Forest Service. And this allows us to really get in there and try and recreate or at least get back to more of a natural condition following the impacts of development over the last 100+ years. So we could jump to the next slide. So Tahoe Resource Conservation District purchased the property in the spring of 2018 with public assistance from the California Department of Fish and Wildlife and the California Tahoe Conservancy, and private donation from the Tahoe Fund and the Barton Family Foundation. We purchased the property to protect some of the most significant floodplain habitat in the Sierra Nevada. The Upper Truckee River is the largest single watershed that feeds into Lake Tahoe, and it's also one of the largest single sources of sediment into the lake, which is affecting lake clarity, fish habitat, and habitat along the entire river corridor. So by purchasing this last big privately owned meadow parcel in the basin, we're able to really get in there and try and mitigate some of those impacts. So that's everything from preserving and restoring meadow and riparian habitats, managing sediment into the lake, storing and filtering water in the meadow so we can bring that water table back up, and providing access to sustainable public open space and natural area, and really allowing people to get in and enjoy this spectacular piece of property. Next slide, please. So a little orientation. Throughout the course of this presentation, we'll be referring to features in the meadow. So the first one you'll see there is what we've been calling the Naturalized Channel. That is the river course along the eastern side of the meadow, kind of on the edge of the Sierra Tract, where the old bridge used to be. What we're calling the Gully Channel, which if you're familiar with the area and you're at the overlook by the STPUD pump house, that's that prominent split. So the Gully Channel, if you're looking north, is the left side channel. The historic channel, which on this map is that really sinuous squiggly line down the middle of the meadow. And then the washed out bridge, which is pretty self-explanatory. That's the old bridge. Now, I do want to address the bridge right here before the onset. I realize that it is a very important connection, and it was lost in a flood event in 2017. As a resident of South Lake Tahoe who loves to bike and walk around town, I know how important that bridge is, and I know how much it's missed. But it's important to note that bridge replacement and ultimately greenway extension from Sierra over to South Avenue and ultimately to the Y is a separate project. It's moving on a parallel track, and it is connected because portions of the greenway and the bridge will ultimately cross the meadow, but that project is being engaged in by El Dorado County. Tahoe RCD is a really important stakeholder, and we are engaged in every step of the way as it affects Johnson Meadow and the Upper Truckee River on that property, but we are not the primary implementers of that project. So the bridge replacement is moving along. El Dorado County has been funded to engage in environmental analysis. So a stakeholder process will begin this winter and into the spring of 2022. And then in the fall of 2022, once the additional funding comes into the county, they'll really engage in the environmental analysis process. So that's CEQA, NEPA, required TRPA analysis, public engagement, and then into design. So design, permitting, and implementation will take it into 2024 or 2025. I realize that this is a protracted timeline, and it's longer than we had all hoped. But in order to make sure that that's done right, the bridge is sited appropriately so it doesn't wash out again. And we are able to accomplish a robust restoration, but also help the county meet South Lake Tahoe active transportation and multimodal transportation goals. We need to make sure that we're really doing that correctly. It is Tahoe RCD's preference that that bridge is located as far south on the property as possible to allow it to be in a sustainable place on the river so it won't wash out again, but also to allow us to have the most robust restoration possible. But again, these are separate projects. The restoration of Johnson Meadow does not incorporate the bridge or the greenway. But because the bridge and the greenway will ultimately cross the meadow, we are heavily involved. If you have any bridge specific questions, I encourage you to email the Johnson Meadow at Tahoe RCD email address, or throw a question in the Q&A, and I will get back to you after this event and make sure that question is directed to the appropriate person at the county. But again, that's moving along. We're hoping that that bridge is in there in 2024, 2025, but Some funding has come in that won't be available until next fall, and the process needs to be engaged in appropriately. If you look at the new bridge across Trout Creek on the east side of Martin Avenue, that's the kind of infrastructure that we're likely going to be looking at. So a lot of work and a lot of planning has to go into that to make sure everything fits and works. So again, I know it's missed and it's a pretty crucial community connection, and we're doing everything we can to make sure we facilitate that process. All right, next slide, please.
And Andrew, I do see a question in the Q&A on that. And like you noted, you'll be able to follow up with that after the fact.
Yeah,
thank you.
I will follow up directly on bridge related questions and make sure they get to where they need to go so we can get you an answer. But again, Tahoe RCD is not the primary implementer of that project, so I can't offer you any more specifics than I have tonight already. So now we're going to look at the study area and the ownership area of Johnson Meadow. So if you look at what's in blue and kind of ringed by the purple, the red, and the orange, that's the Johnson Meadow property that's under the ownership of Tahoe RCD. That's where the primary restoration and the primary project is going to be. The purple areas, that's all private property. And then you'll look at the kind of red and the yellow and that little light blue sliver. That is the city of South Lake Tahoe, the California Tahoe Conservancy, and then South Lake Tahoe Public Utility District. The Public Utility District does have significant infrastructure in the meadow, so we are working with them to make sure that we maintain access and maintenance access to that. But we're also working with the city and the Conservancy and the Forest Service to make sure that we have appropriate staging and access routes as well. So if you kind of look at those strange outlines that extend out of the blue area, those are some potential access routes and staging areas for material like fill gravel, fill soil, or when we ultimately get to implementation, when we have to bring machinery into the meadow to get the work done. So that's what those are. Those aren't set in stone. We will be engaging in an analysis process during our phase 2, which will follow this, and we'll talk about that when we get into next steps to really make sure that our access routes are sustainable, appropriate, and disturb the adjacent neighborhoods as little as possible. I live in one of the adjacent neighborhoods, so this is an important aspect to me as well. So it's important to remember that the primary work will be happening on Tahoe Resource Conservation District property. And with that, I believe I will hand it over to Adam to give a little more context on the project, and then we'll move through and next steps.
All right, thanks, Andrew, and good evening, everybody. Again, my name's Adam Lewandowski. I am managing the technical consultant team that's working with Tahoe RCD on the design and the planning for the restoration project. So I'd like to talk a little bit about the current state of Johnson Meadow and why we're proposing this restoration project. Next slide, please. So Johnson Meadow has been affected by a number of historic practices, including the clear cutting of most of the watershed during the Comstock era in the mid-1800s, and the urban development in the surrounding watershed that reduced the ability for precipitation to infiltrate into the soil. But most of the direct effects on Johnson Meadow were from the dairy and cattle operations on site. And so as part of those operations, the river was redirected to the east side of the meadow into what we're calling the Naturalized Channel. And that was really intended to dry out the meadow earlier in the spring so that the cattle could get out there and graze earlier in the year. Then a series of dams and gates and ditches were used to divert some of the river water back into the meadow to allow the grazing to continue into the later summer and fall. Over time, more and more of the river flow entered those irrigation ditches. And then in the 1997 flood, the Gully channel captured a lot of that flow, and that really became the primary flow path, which created a much straighter and deeper channel than would have naturally occurred. Next slide. So in its current condition, the river channels are deeper and larger than they would be naturally. And that means that the water gets out of the channel onto the floodplain less often than it should. And so this leads to a whole host of issues. It results in the groundwater level that's lower, which affects the health of the meadow vegetation. And when they're properly functioning, floodplains serve as a natural filter that remove the pollutants from the water as the water gets out onto the floodplain, spreads out, and slows down. But in its current condition, Johnson Meadow provides a lot less of that natural filtration than it used to. There's also increased erosion of the channel bed and the channel banks, which creates a direct source of sediment that flows right into Lake Tahoe. In its current state, Johnson Meadow also has degraded habitat, both for fish and other aquatic organisms that live in the river, as well as for wildlife species that depend on the meadow vegetation and the riparian habitat along the river. These drier meadow conditions also contribute to an increased fire risk because the drier meadow vegetation is more susceptible to fire, and because with a lower groundwater level, it allows conifers to move into the meadow over time. Next slide. So that's a quick summary of the current degraded condition of the meadow. And I'd like to now go over some of the reasons that we're proposing this restoration and some of the benefits that we hope to achieve. So next slide. So the graphic on the bottom here just shows kind of a conceptual comparison of a degraded river channel on the left and a restored river channel on the right. And with the larger degraded channel, most of the water remains in the channel, even during the big spring runoff events when there's a lot of water moving through the system. And so that water is conveyed right to the lake without getting out of the channel onto the floodplain. But with a restored channel, like the one shown on the right, the floodwater gets out of that channel and spreads out into the floodplain more often. And so that's really what we mean by increasing floodplain inundation, getting that water out of the channel onto the floodplain more often. And so that really has multiple benefits. It allows the floodplain to act as that natural filter. And again, when the big flows come through, the water gets out of the channel, it spreads out on the floodplain, the water slows down, the sediment drops out of the water, and the nutrients are taken up by the vegetation in the meadow, so that the sediment and the nutrients end up in the meadow rather than being transported right to the lake. By getting those flood flows out of the river channel, it also reduces the amount of river channel erosion. There's less water, less force on the channel creating that erosion. It also raises the groundwater level, which increases soil moisture. And this allows the meadow vegetation to thrive. And it also helps to keep flow in the river channel throughout the year as water gradually seeps out of the soil back into the river late in the summer. In a restored river, there also tends to be more overhanging vegetation on the banks that hangs over the channel and shades the water. And the river will also create a natural system of shallow riffles followed by deeper pools. And so all of that really benefits aquatic habitat for native fish and game fish and other aquatic species. The higher groundwater also enhances the willows and the other riparian vegetation that grows along the river, which improves habitat for birds and other wildlife. And while wildfire protection isn't a major goal of this project, a wetter meadow that stays moist later into the summer can be less prone to fire. Next slide. So I know the Caldor fire is on all of our minds, and this map shows the Upper Truckee River watershed with the boundary in blue, and it shows the area burned by the Caldor fire in yellow. And as you can see, the Caldor fire burned a portion of the watershed upstream of Johnson Meadow. And just for reference, Johnson Meadow is shown in the black outline there kind of towards the lake, right there. And so this burning in the upper watershed can result in a few potential impacts over the next several years. For one, there's the direct loss of habitat within the fire footprint as the trees and the vegetation are burned. But there's also an increased risk of sedimentation. That is, without the ground cover and vegetation in the burned area, there's a risk of increased erosion in the upper watershed that can result in more sediment being transported through the Upper Truckee River. And then there's also a chance that the peak flood flows will be higher because there's less vegetation in the watershed that's taking up that water as it moves through. So I do want to be clear that there is a separate burned area restoration effort that's going on. And the Johnson Meadow project is not specifically intended to address the Caldor fire. But the restoration of Johnson Meadow can have some indirect benefits. And that includes by helping to filter out the increased sediment that would be moving through the upper Truckee River, and also by providing that floodplain space for those increased flows to spread out and slow down. Next slide. So that was a summary of some of the environmental benefits of restoration, but we also recognize that Johnson Meadow is important to people for many other reasons. And so the restoration project is also being designed to achieve the other objectives listed here. None of the restoration alternatives propose significant access improvements or any kind of recreation infrastructure, but they do all allow for continued public access and use of the meadow, similar to the types and the level of use that occurs out there already. All of the restoration alternatives recognize that rafting and kayaking in the river is important, and all the designs would maintain those rafting and kayaking opportunities. The designs are also intended to protect scenic views and to achieve a natural looking meadow that doesn't have a lot of visible human-made or engineered structures. The alternatives are all designed to protect nearby property, and that includes by not increasing the flooding risks to nearby property owners, as well as by protecting those utilities and other infrastructure that's in the meadow and right around it. And we want to make sure that all of the designs are practical, they can be funded, and they're cost effective. Next slide. So just to give you a sense of where we are in the process and the overall timeline, I know many of you probably attended the workshop that we had a little over a year ago. Since that time, we've spent most of the past year developing 3 different restoration alternatives, and we're hoping to get your questions and your feedback on those tonight. Then this winter, we'll perform an initial evaluation of the alternatives. And then next year in 2022, we expect to begin an environmental analysis and to prepare the required environmental documentation for the project. After that, there will be additional design work, with project implementation still being several years out. So with that, I'd like to turn it over to Toby and then to Brent, and they will provide an overview of each of these alternatives and then give a brief comparison of the alternatives. So Toby, over to you.
All righty. If we could get the next slide up. So the question then becomes, how do we take these objectives of restoring the meadow and actually get to the point of developing alternatives? And one thing that we'll discuss up front is we can't take a step forward until we kind of arrest the negative processes that are already going on in the meadow. So Brent's going to talk about the alternatives, but they all have several things in common. The most important being, we want to fill that gully channel. In other words, we don't want that thing to be active or conveying any more flow, because it is straight and it's a lot of erosion has been occurring. So we're going to get rid of the gully channel. The second commonality for the alternatives is that since we're going to try and get water out onto the meadow surface through various means, we know that that water has to somehow get back into the river above the above the Highway 50 bridge. So, and Brent will discuss this a little more detail, but basically we need what's called a grade control structure to allow water up on the meadow surface to drop back into that channel in a way that it doesn't start a whole new gully channel. So those are 2 common things. Now, in terms of the actual alternatives, we kind of looked at a more global picture of the entire system, starting from the headwaters and going all the way to the lake. And one thing that happens along that route is that the valley gradient itself becomes less and less. And that in turn affects how much energy a stream has in terms of moving sediment. And we know that there's a lot of sediment that likes to move in that river, and it's problematic at various stages. So as we move downstream in a big system, we tend to see the upper headwaters have a lot of energy, and they can be erosive. The kind of the middle part of the system we call transportational, where we're moving sediment along, but we're not necessarily generating more sediment. And then the bottom end of the system, as it approaches the lake, we can often call that deltaic, similar to a delta, where the stream's kind of running out of gas, doesn't have any more energy to move sediment. And a lot of times you'll see channels, multiple channels leading away from the main channel. So when you look at this photograph here, you'll see that what we call the historical channel. And we thought that is a prime opportunity for us to get water back out on the meadow and do it in a way that kind of resembles what we suspect was there before. And maybe that surface had more than one channel like it before the Comstock era. So we looked at that historical channel to see just how much capacity it has. And we looked at it in terms of some standard engineering computations to compute its capacity. We looked at its what we call the plan form, which means what does it look like in an aerial view? And there you can see it's a pretty highly meandering squiggly line. And we looked at analogs throughout the Sierras and in some cases over the entire country to see what channels have in terms of capacity and plan form where we're dealing with a similar flow. And in our case, we're dealing with the kind of the target flow that we'd like to convey if we conveyed all the flow in a single channel would be about 370 cubic feet per second. So that historical channel, when we went through those computations, we found that the actual capacity, while it's not certain, we think it's in the vicinity of 60 to 80 cubic feet per second. It has a plan form consistent with that capacity, meaning that you look at other analog channels of that type, and they seem to have a similar capacity. And then the one thing that was very interesting about the historical channel is that it's actually tending to be in an elevated position in the meadow, which is pretty unique. And we think that's associated with natural levees building up next to that channel over a very, very long period of time, where during big events, sediment tries to leave and flood out onto the meadow surface, but the meadow is so coarse that it captures that sediment right away and tend to build up a little levee alongside the bank. So based on that, we knew that we couldn't convey the entire flow of the river. So at that point, we know that we're going to still, the alternatives that we've reached all utilize still the naturalized channel. But the concept is how much can we take high flows and introduce them into that historical channel and to find other ways that we could spread water out onto the meadow. So with that restriction and the capacity, the alternatives spin around the idea of how much of that, the high flows can we put out on the meadow without running into problems with sediment deposition in that historical channel, and what period of time we're talking about. So with that, I'm going to turn it over to Brent.
Hey, everybody. My name is Brent Wolf. Good evening. I'm an engineer with Northwest Hydraulic Consultants. Toby, I don't think you reintroduced yourself, but Toby's a hydrologist with Northwest Hydraulic Consultants. And Toby's presentation role was sort of to set the stage for me to describe for you these alternatives and kind of give you the bookends on why we arrived at what we arrived with these alternatives. We have 3 alternatives for you that I'll show you here. And really, I think that the take-home point that I wanted to make, starting with Toby's sort of lead in, is that we sort of, through our feasibility analysis, arrived at some fundamental things that we thought were necessary to do. And number one, and essentially, if you're here wondering, well, what's going to happen to the river in these alternatives? Toby sort of mentioned it, but what we call the Naturalized Channel, which is the portion of the channel there that's being highlighted in the cursor along the eastern edge of Sierra Track, under all 3 alternatives, that channel would remain the low flow or base flow channel. As Toby described, we looked at how much water we could get into the historical channel. We made the determination that we can't get all the water from the Upper Truckee River successfully into that system. So basically what you're going to see from these alternatives is that we just push a little harder and a little more to get the amount and the frequency of water onto Johnson Meadow from these alternatives. They increase as we go through these alternatives. So what you have on the screen right now is sort of an engineering schematic of the features in alternative 1. And as Toby described, there's certain features that are across every alternative that are the same. So the first feature I'm going to focus on is there's a little symbol called 1A1 on this little figure. Hopefully you can see it. That's filling the gully channel. So the idea, and this is across every alternative, is to fill the gully channel. This is probably the main degradation we're seeing out in Johnson Meadow right now. And so this would be filled to the existing meadow surface. The other feature that's common across all alternatives is what we call the grade control structure down at Highway 50. So what our objective is here is to bring water back onto the meadow surface. And when we bring water back onto the meadow surface, it still needs to get back into the Upper Truckee River and cross at the Highway 50 bridge. So in doing this, we're going to create what we hydraulic energy or forces, where it is going to come down from the meadow surface back into the Upper Truckee River. And if we didn't have this grade control structure, those forces could generate what we call a head cut or erosion at that location, and actually then erode back up into Johnson Meadow and form a new gully channel. And that would obviously wreck everything we're trying to do here in terms of restoration. So the intent there of that grade control structure is to hold the bed of the Upper Truckee River and to basically not erode from erosion as flows from the meadow are returning to the Upper Truckee River. That type of grade control structure is primarily buried. So basically, by definition, we're just trying to hold the bed or the grade of the river at a certain elevation. So it would be in the river, it would be buried in the bed and the banks. And you would see, if you were floating on the river, you would go through a riffle or a chute, but it would just be a faster section of moving water is what you would see out there. And then the last thing that's common to alternatives, which you can't really see here, but which is an important piece, is that STPUD's sewer line, which serves a major portion of South Lake Tahoe, crosses through the meadow. And so all alternatives have considerations for continuing to provide STPUD access to that sewer line and to protect the manholes. So those are sort of the 3 things that are common between the alternatives. And actually, one thing that I think I forgot to mention, I think Toby, we forgot to mention, is that right early on in this process, the project team, that's TRCD and everyone involved, decided that new channel construction was not desirable. So if you're familiar with other projects on the Upper Truckee River, there have been certain projects where a completely new Upper Truckee River channel was built and the old channel was filled or abandoned or modified. This project does not contemplate new channel construction. So none of the alternatives create large new sections of the Upper Truckee River. As I mentioned before, the low flow or base flow would remain in what we call the naturalized channel. So back to the naturalized channel. In alternative one has the least amount of changes. Basically, what we're doing is enhancing the naturalized channel. That's, again, the channel along the Sierra Track. So right now, there's a lot of woody debris in that channel. Basically, that material would be removed or rearranged to make sure there's a low flow channel in the naturalized channel. And then on the left bank, and we look at rivers and we look downstream. So the left bank is on the opposite side of Sierra Track along that channel. We have these enhancement benches, we're calling them. So those would just be depressions on the left bank that would lower the left bank to bring in some more riparian vegetation and some more habitat on those. So subtle adjustments. And then the main thing that we do in alternative one, and you'll see that we build upon this theme, is we construct a tie-in channel to the historical channel that Toby described. So that's being circled right there on your screen. This tie-in channel essentially would be a swale that would connect the Upper Truckee River to the historical channel. And as flows were higher in the Upper Truckee River, roughly 300 cubic feet per second or higher, water would start to go into the historical channel. So basically, it's a high flow connection into the historical channel. One other point I want to make, because you probably see it on this figure, is, and I know Andrew talked about it at length, is we kind of show for you the location of a bridge and the boardwalk. That's a future project, obviously, as Andrew mentioned, is being planned and designed by El Dorado County. We are not involved as engineers in that portion of the design, but we just put it on this figure here to give you some idea of a potential location for it. And again, El Dorado County has potential alignments, and that's their portion of the project to plan and design that. Next slide, please. So this is still alternative one. This is more of an illustrative view of the alternative. And really what we're focusing and showing you here is, again, the base flow is maintained in the naturalized channel. You see the historical channel is there. It's got a little blue around it to show it's getting wet. And the idea here in terms of where we're returning the meadow to is a lusher, greener, healthier, wetter meadow. You can also see in this figure the connection points for the trail system and the future greenway that would cross through the meadow. And again, that's a very preliminary alignment that will depend on El Dorado County's planning process. So that's alternative one. I do have results to show you on all these alternatives for how they affect meadow wetness and inundation, but that comes at the end. So next up is alternative two. So alternative two, again, we have some very similar themes with filling the gully channel and the grade control structure. Where alternative two starts to differ from alternative one, and it's a little hard to see obviously in this plan view, is we are trying to get more water into the historical channel at lower flows in the Upper Truckee River. So how we accomplish this is essentially we would build up the profile of the naturalized channel through smaller grade control structures. So all those little symbols along the naturalized channel you'll see, those are small distributed grade control structures. So similar in concept to the large one down by the Highway 50 bridge, but these would be small in scale in terms of they would raise or hold the bed of the Upper Truckee River by maybe 1/2 foot to 1 foot each. So, and they'd be buried in the bed. So really small structures. And the intent there is to raise the profile of the naturalized channel till we get closer to the tie-in channel in the historical channel. And the idea there where you see that pink area is we would constrict the naturalized channel in that location to be narrower. And when we constrict the channel to be narrower, it'll raise the water surface elevation behind that area to then force more flow into the historical channel. So it's a bit of hydraulic modifications, we would call it, to passively get more water into the historical channel more often. Again, the main flow, low flow, would still be in the naturalized channel. It would just spill over more frequently at lower flows in the historical channel. Next slide is an illustrative view of this. Very similar to alternative one. As you'll see in the results section here at the end of my presentation, there is a little bit more inundation that actually is created by this alternative, and it's certainly more frequent. Last slide. So alternative 3 is what we would call the multi-channel alternative. So in this alternative, it's very similar to alternative 2. It has the same grade control structures, the same constriction to get more water out in the historical channel. But in this alternative, we add another tie-in channel where the cursor is right there. The intent of this tie-in channel is to get more water into a secondary swale system, more on the western side of Johnson Meadow. So in this, and this channel would also activate about the same amount of flow in the Upper Truckee River as would activate for the historical channel. So in this alternative, we're starting to get more of a branched or distributed network of multi-channels that are flowing through the meadow to wet it as much as possible. I think we have another illustrative slide on the next one, and essentially very similar, but this alternative is the alternative that would provide the most inundation the most frequently of Johnson Meadow. So the last slide I have for you is the next slide. So these are model results. So we run models. This is actually a two-dimensional hydraulic model that ran these results. And what I am showing you here is a comparison of how inundated and to what depth the meadow would be inundated if you were to have a flow of 400 cubic feet per second in the Upper Truckee River. So why 400 cubic feet per second? Toby alluded to it in his presentation, but from a contemporary standpoint, and in other reaches, especially upstream of this reach, basically 375, 370 CFS cubic feet per second is the bank full discharge for the Upper Truckee River. So what that means is that around that volumetric flow rate, the Upper Truckee River starts to spill over its banks. And that's where we believe that everything's in equilibrium with the system, based on various geomorphic and hydraulic processes. So that's why we look at this flow rate, is we want to see how we're doing against that metric. For comparative purposes, I looked it up. Right now, the Upper Truckee River is flowing at 5 cubic feet per second. That's about as low as it gets. You know, we're in the late fall here in Tahoe, and we've had a really dry year. 400 cubic feet per second is going to happen predominantly after a large snowmelt year in spring runoff. So that's predominantly when you would see, what you see on the screen here is predominantly the condition you would see during a fairly decent snowmelt runoff year. You could also see over 400 CFS easily during a rain on snow event, but predominantly you would see it during the peak of snowmelt runoff in the spring. So what we're seeing here, and I'll go left to right. So this is existing conditions and through the three alternatives. So the left side shows you currently what happens in Johnson Meadow at 400 CFS. So this is the condition we are trying to restore from. Basically, we want the Upper Truckee River to go over its bank, you know, by 370 CFS. In Johnson Meadow right now, it does not. A lot of flow goes into the Gully channel, and it doesn't. Alternative one, you see we do markedly improve that condition for this targeted flow rate. We go from roughly 14.5 acres of inundation, which is basically the channel right now, to about 75 acres of inundation. In alternative two, we don't increase greatly the area, but we do increase the frequency. So what I mean by frequency here is we look at the long-term record of flows in the Upper Truckee River, and basically we would have a wetter meadow that's more close to this condition in 20% of the flows as relative to 10 in alternative one. And again, that's happening because we're constricting the channel so that it backwaters more and spills more often into the center of the meadow, roughly 20% of the time. In alternative three, we're trying to get more of the western edge of the meadow wet by that second or multi-channel system. And you see we do accomplish that to some degree. We get about another 15 acres of meadow wetness under alternative three. So that's sort of how these alternatives compare, obviously from our standpoint, which is purely on meadow wetness restoration. One last point I'll make is we did take these same models and we looked at flood impacts. So we ran these same conditions in our flows, but now we change it from 400 cubic feet per second to 7,600 cubic feet per second. So 7,600 cubic feet per second is a big flow. That's the FEMA 100-year flow. And so we look at that to see if these changes would have an impact on floods. And the short answer is they do not. What we see in those, and I don't have a figure for it because there wasn't really anything to show, is under a really high flow like that, the constriction or the control is actually at the Highway 50 bridge. So all that water has to come from the meadow and get through that small opening under a big event at the Highway 50 bridge. And what happens during that big flood event is that constriction point causes essentially a hydraulic traffic jam, and that water cannot efficiently get through the bridge, and it backwaters the whole Johnson Meadow. And it does that with such an effect that these changes we are doing on the meadow surface do not have an impact on the overall flood event in terms of water surface depths for that 7,600 CFS cubic feet per second flow. With that, I do see a bunch of questions popping up on the Q&A. I will turn it back over. Toby's raising his hand.
I wanted to jump in because I feel remiss that I kind of blew it on the engineering channel. I set the stage, but I think the real point is that from looking at the big picture as it is described, going down the entire valley system to the lake, it may have been the case, and we think so, that there was never a single channel in that area of the river system, so that the Johnson Meadow probably was a had multiple channels in it. Certainly that historical channel had been there for a long, long time and represents a piece of what was going on there prior to the Comstock. So we see use of building a single channel in there is not appropriate here, and certainly not nearly as effective as having a multiple channel system or multiple opportunities to spread water over a greater extent of the meadow.
Thanks, Toby and Brent. So are there any final points you'd like to make before we dive into our questions and comments? Okay, and Adam and Andrew, you might want to join us back on screen again. And, you know, I think it might actually be useful if we leave the previous slide up. It's a nice comparison of the alternatives. And so at this point in time, I do see a number of questions in the Q&A, and we certainly welcome more. I am going to try to take the questions first, but some of them are intertwined with good comment suggestions. So we'll do what we can to be efficient, and I'll sort of group these together for our presenters. So what I'm seeing right now, and team, you know, please do also jump in as you see others, but are a number of questions and comments around plans to work on the meadow on the other side of 50, questions about what the potential, you know, to expand restoration outside of, you know, this specific project area, what benefits could that bring, and some notes there. So a question from Toby about plans on the other side of 50, some comments and questions from Robert about the benefits in the future if some of the high flows could be distributed through culverts under the Highway 50 bridge and to surrounding private property. And also a question from Lisa about any plans to buy up property along both sides of 50 to restore a larger area for flow. So maybe if we could try to respond to those together. Yeah, Adam.
Sure, I can start with that response. And yeah, there actually is work that's going on right now on the meadow on the other side of 50, moving downstream. So much of that area is owned by the California Tahoe Conservancy. And there's no work immediately downstream of Highway 50, but a little bit further down as you get towards Cove East, there is active restoration work going on right now. And that's the Upper Truckee Marsh Restoration Project. That was a long time in planning, and through that planning process, the Tahoe Conservancy did look at the entire property all the way from Highway 50 down to the lake. And so one of the things they did consider was trying to pass more of the flow under the highway, like I think Robert had suggested in his comment. They looked at trying to put more culverts under the road so that those flows can pass along the floodplain, don't have to go back into that constriction at the Highway 50 bridge. And I know the Tahoe Conservancy has been actively looking at trying to buy up property where they can. They have an acquisition program that buys up property from willing sellers, and so I think that's something that they've certainly been pursuing. Looking at purchase of private property when those property owners are willing to sell to allow for more restoration. So that's not something that's included in this project because those areas just downstream of Highway 50 near Motel 6 and the old Caro's restaurant are still private. So there's really nothing we can do right now. So these designs with the grade control structure to get the water back under the bridge are intended to be functional kind of in the existing setting that we have. But that doesn't preclude some kind of future project. If those properties are required, there could be a future project that could go in and could expand the bridge or could put a series of culverts or something to try to continue that flood flow under Highway 50 and get rid of that constriction.
Thanks, Adam. Any other comments from the team on that before we take the next one? Okay, sounds like we had covered that. So the next question I see is around anticipated maintenance, and Brent and team, this might be for you. Gavin asked if there's a chance the flow control structures or channel constriction on the naturalized channel will fill full of sediment during a large sediment flow event, and what that might mean for maintenance.
You want to start, Toby?
Sure. One of the advantages of the structure that we're talking about for where we tie in to the historical channel is making it primarily a constriction rather than like a low weir or dam to raise the water surface sufficiently that we can get water into that historical channel. With a constriction, you get the benefit of raising the water surface, but you're actually accelerating the flow in the channel. So I'm not at all concerned about having sediment, clog that constriction. There is certainly an awareness that we need to look at the potential for sediment deposition in the tie-in channel itself. I think that's where we're going to devote a lot of time to see and ensure that that tie-in channel doesn't get clogged. But it is a concern, I would say, for the tie-in channel itself, but not at all for the naturalized channel.
Thank you, Toby. All right, I'm going to move down the list and shift gears just slightly here. I see a question from Paula around recreation access and whether the alternatives presented would eliminate tubing or paddling opportunities.
And I can jump in on that. It is not our goal to eliminate any tubing or paddling or river recreation opportunities, and we are considering those in all of these alternatives. Though the Gully channel is the primary channel that's used right now, that, you know, as mentioned earlier, is not a natural channel. It's a captured irrigation work. So though the river course, it will be different, those opportunities will still exist. Inundation in the meadow will happen more often and will cover a larger area. But the naturalized channel, the current main stem of the river will remain, and, you know, will be navigable during certain parts of the flow. I mean, there are large log jams in there. What to do with those is yet to be determined. But boating and paddling and floating will still 100% be permitted and encouraged on the river. Just the course and kind of where you're taking your boat is going to change. So we are not trying to eliminate any recreation opportunities. We are hoping to maintain those, but improve river and meadow function by eliminating that gully channel, so we get more of a natural flood during runoff and flow events. So you'll still be able to get out there and you'll still be able to paddle and float.
Thanks, Andrew. All right, well, let's pivot again. I see a question here around the preliminary analyses done and climate change impacts. And Rebecca asks whether this team has done preliminary analysis of the alternatives and how they would respond to predicting climate change precipitation patterns. So more rain on snow events, more early peak runoff, and noting that this will be important to show as part of the environmental analysis. So I'm wondering if the team can respond to that part of that. That's the question about whether preliminary analysis around this has been done.
Yeah, I can start with that one, and others may want to jump in, but that is something that we would take a closer look at in the environmental review and the alternatives evaluation process. But I do want to mention that, as Brent described earlier, none of these alternatives actually construct a new channel. And so others may want to weigh in on this, but I don't think that the design isn't as affected by calculating the exact future flows as it would be if, say, we were constructing a whole new channel. But in general, the restoration benefits should help to address some of the impacts of climate change. So with more rain on snow, potentially more rain event, we might have more frequent or higher peak flows. And so by getting those flows out on the floodplain, that's going to help to address and to mitigate some of the erosion, the impacts that could otherwise occur from that. Similarly, by raising the groundwater levels, that can help to mitigate some of the effects of longer droughts and higher temperatures by keeping more of that water in the soil and allowing that to trickle out over the year, rather than just having it kind of run right through in a big flashy flood.
Thanks, Adam. Any other thoughts from the team on that?
Well, just to be frank, we don't exactly know. Nobody does, but certainly we would expect a trend to have perhaps more rain on snow events, but perhaps a declining trend in the snowpack, neither of which is good. But as Adam stated, I think the alternatives are built around some fairly simple objectives to achieve. And while we don't know what's going to happen with climate change with any kind of precision, we do know that these alternatives are taking energy out of the system. And when we do that, we're going to reduce erosion. If we can disperse that energy from a high flow event out on the meadow surface, we're really, it's kind of a win-win. We're taking that energy out of the channel where it can do some erosion and spreading it out where it really is incapable of doing any erosion. So yeah, I wish we knew more, but we're trying to be as sensitive to that type of issue as we can be.
Thanks, Toby, for your frank response there. I do see another question that relates to the analysis done thus far. Aaron asks whether the alternatives quantify enhancements to wildlife habitat.
Yeah, and that's not something that's been quantified yet. Really at this phase, we were focused on developing the alternatives that meet those objectives that were described earlier. We've done some quantification like shown on the screen here of the floodplain inundation. And in large part, that's going to be what helps to enhance wildlife habitat just by getting the flows out there, re-wetting the meadow. But there will also be an additional alternatives evaluation process that'll take a closer look in comparison of these alternatives and try to quantify more of those benefits where we can to help the Tahoe RCD select a preferred alternative. So yeah, I guess the short answer is no, we haven't quantified that, but to the extent that stuff can be quantified, that'll happen in that alternatives evaluation.
And Adam, similarly, I see a question around what type of plantings will be done to improve habitat. Is that a level of detail that we have at this point?
We don't have that level of detail yet. These are conceptual plans. Some people refer to them as around a 30% design plan. So we've still got roughly 70% of the design work to go, including identifying the specific plantings. But in general, it will be native species, native willows and grasses and sedges and forbs and native wet meadow vegetation.
Thanks so much. So I do see a few more questions that are related to restoration design here. So Chris is asking about whether we could elaborate on proposed measures to control erosion to properties on the east side of the river. And I know we did also have a question from Gail about where the soil would come from to fill the Gully channel and how many yards of soil might be required. So Brent, I'm wondering if we could look to you to elaborate a bit on those topics.
Sure. For the first topic on erosion, there is a couple things I glossed over that were smaller items in the presentation, but there is some bank stabilization, particularly around the STPUD pump house that is needed that's in alternatives. As Toby discussed, a lot of these alternatives essentially would, during any type of event that has a lot of water flow, are spilling onto the meadow. And as we spill onto the meadow, we are reducing energy in any channel. And so by the nature of some of these design intents, like at what you see in this graphic's pretty good. What you see in the existing conditions is that all flow, all 400 CFS is coming down and going into either the Gully channel or Naturalized channel. So you have a lot of flow concentrating in those channels and exacerbating problems with bank erosion. These alternatives, besides targeted restoration in areas to enhance and protect, like say the Naturalized channel, we see all these alternatives is that same flow rate is distributed across the meadow. So a lot less energy and a lot less flow would be in any one channel under these alternatives, which in turn reduces the risk of erosion by distributing that energy across the meadow and not concentrated in these channels. The estimate on the Gully channel, depending on how we fill it, is somewhere between 20,000 to 25,000 cubic yards of material. So it's quite a bit of material. We are still looking at the best possible sources for that. There are possibly some options for it on conservancy property located relatively close to this project area, but the exact source of fill material for the Gully channel has not been defined, at least at this point.
Thanks so much, Brent. So I am seeing a few questions, one asking to reiterate some of the notes on the anticipated schedule and next steps if you missed the first part of the meeting. And then a few that are asking about what might be the most desirable alternative. And to me, that seems like a bit of a process question. So while I know we want to come back and catch some of these more specific questions, I'm wondering, Andrew and Adam, if we could go to you for just a quick recap of where we are in the process and how that relates to alternative comparison and eventually an alternative selection.
Yeah, I can start that answer. So we are kind of in the closing stages of what we're calling phase one, which is a preliminary process. So these are conceptual 30% designs. They do not represent, a final suite of alternatives. Once we complete this phase, we'll enter into a phase two process, which is going to be our environmental analysis. So that's our CEQA, our NEPA, our TRPA required analysis and considerations, and that'll include an alternative comparison, biological assessments, all of the various assessments and analysis needed to come up with a suite of final alternatives from which we'll select a preferred alternative. So really, we're looking at several years of environmental analysis in the phase two, and then moving into a permitting and implementation phase. So realistically, we won't get to a point where we're actually looking at starting construction until, I would say, 2025 at the earliest. Restoration, particularly restoration in the Lake Tahoe Basin, is a very long and protracted process, and that is due to the required analysis to make sure we're really kind of crossing our T's here. So we're still really early in the process. This is a lot of the preliminary work that we're doing to set the stage for our next phase, which is our phase two process, that I can go over a little bit more in the next steps, unless we want to address that here. Did that adequately answer the question?
I think so. And you're right. Let's come back to that at the conclusion of our discussion here. Let's see if we can take a few more of these detailed questions first, and then it would be good to wrap up with next steps. So
Nora?
Yeah, please.
Could we take Lori Kemper's question?
Absolutely. I'm scrolling to find that one. There we go. So Lori, you had asked whether there could be an alternative that allows low flows to reach the historical channel so that it gets water every year and not only during high flows. And you note that it would be nice to get flow in the historical channel more frequently and rewater a larger percentage out of the year. And a follow-on to that is, does the Gully channel need to be filled the entire length, or can ponds or pockets be allowed to reduce the amount of fill required? So there's a lot in there, Toby. Take it away. Okay.
For the second part, I think that is something that we would definitely look at. It's a possibility. The last thing we want to do is develop a situation where we could link up those ponds again with flow paths. So one of the other things we're looking at in terms of the design is adding roughness elements on the floodplain itself through vegetation to, again, keep the opportunities for flows reconverging and creating that kind of problem. But I think that is something that we'll get to. The first part of your question is something that we all wanted. That was something we all wanted when we started this process. There was a lot of head banging that went on, was like, why can't we do that? And that was why we really looked at that historical channel. And it's basically a problem of the fact that the historical channel is really high elevationally and the naturalized channel is very low. So the only way to really get low flows in that channel, well, there's two ways. You can either pump water into it, which I don't think anybody wants to be dealing with that. The other would be is to have a diversion into it, but because it's so elevated, that channel is so high, relatively high, we would have to take that diversion basically back where the airport runway is, just about to be able to have a gravity flow into that historical channel. And at very low flows, then what tends to happen is that as soon as we get any kind of sediment bedload movement in the channel itself, it tends to block off that diversion channel with sediment. So it becomes a maintenance headache. That was something we all wanted, and we just came to the conclusion it just was infeasible.
Thanks, Toby. And I see, Lori, thank you for your note that makes sense. And Toby, I see another question here that might be appropriate for you to answer. Paul is asking about the current existing conditions with the river never going over banks, and she knows she's seen the meadow flooded. Is what we're seeing there not an actual flooding event?
I think I could answer that one.
Okay.
So the meadow does flood. It floods, though, at a flow rate higher than what we're showing you here, which is 400 cubic feet per second. So this is kind of, it's why do we pick 400 cubic feet per second? Well, contemporary thinking is that we want the upper Truckee River to go over its bank at 370 to 400 CFS. So that's why that number's on the screen. That's why our models do it. But you will, if you get, we don't have the figure here, but we do have other model runs in existing conditions. Say when the flow is twice what we're showing you here. So when the flow is 800 cubic feet per second. And that's when you start to see Johnson Meadow really wet. So basically, what we're trying to do with this project is to get it wetter more frequently, and certainly more frequently than getting it wet at 800 CFS. But yes, Johnson Meadow does get wet, just at higher flow rates than we feel are desirable from a restoration standpoint.
Thanks for that, Brent. Okay, I still see a couple of recreation questions, and I know we had talked previously about the ability to paddle and float still being maintained, but there is a question about walking and biking access, and as well as a question about which alternative would keep the naturalized channel as the main recreational channel. So Andrew, you might be the best person to kick us off with recreational access, and then we can take additional detail from the team.
Yeah, I can jump in there. None of the alternatives change the current access. So in every single one of these alternatives, you will still be able to access the meadow from the same access points that exist now. The trail on the edge of the Sierra Tract, kind of that goes down, I believe it takes off from somewhere around Armstrong and heads down to Barbara. That will still be accessible. That will still be there. You'll still be able to walk in and access the meadow from the current access points. So none of that will change. As far as, and Brent or Toby jump in if I've got this wrong, but as far as which alternatives keep the naturalized channel as the primary flow channel access for recreation, all of them do that. So under all of these alternatives, when flow rates are high enough to support boating, you will be boating in what we've been calling the naturalized channel, or that channel on the east side by the Sierra Tract. So just to reiterate, none of the alternatives will change or modify current recreational access. You'll still be getting there from all the same points, and all of the alternatives maintain the naturalized channel as the prime recreation channel.
Thanks, Andrew. So we are getting closer to the end of our time together tonight. So if you do have additional comments and questions, it's a good time to post them into the Q&A so we make sure we get to them. But I do see one that we haven't addressed yet, asking whether there will be any conflicts between the airport and increased bird habitat.
Yeah, that's,
sorry. That is something that we will be considering during our phase 2 analysis as part of the environmental. We don't, at this time, we don't anticipate that there will be enough increased ponding, in the vicinity of the airport to cause that conflict, but we will be looking at it more in detail during the next phase.
Thanks, Andrew. All right, so what I am seeing in terms of remaining questions and comments are some process questions and next step questions. And so I'm wondering if at this point in time, we would like to pull up our next step slide.
Yeah.
And Andrew and team, if you are, there is a question about how to stay involved. There are questions about how property owners, can stay involved as the process marches toward a final decision. And there is a question about how the environmental document might address or make possible, other future options and projects that would work with this restoration. So to the degree that you can respond to those as you talk about next steps, that would be great.
Yeah, I can jump in and then maybe pass it off to Adam here. And there are a couple of questions about our current preferred alternative as well. At the moment, we have not identified a preferred alternative. That will be part of the early parts of phase 2 when we get into environmental, and that's for process reasons. We through the analysis will be able to determine which alternatives provide the most meadow wetting, but also, cause the least amount of conflict and, additional impacts to surrounding resources. So that'll be part of the phase 2 process. And then getting into how to stay involved and stay informed. If you're not yet signed up for the email list, please do that. There should be a widget on the Tahoe RCD website that will allow you to do that, Tahoe RCD / Johnson Meadow. If you are at this webinar, you will be added to the list if you're not on there. I will make sure of that. So we'll send out emails alerting you to opportunities to get involved. But when we move into phase 2 and we start the environmental analysis process, that starts with a process called scoping, which is a public and stakeholder involvement process that allows adjacent landowners, interested members of the public, additional agencies, other stakeholders to raise concerns or considerations that should be considered during alternative analysis and subsequently during the analysis process. So there are going to be additional opportunities for landowners and interested members of the public and stakeholders to be involved to influence this process. So, I encourage you to sign up for the email list and to stay involved and keep an eye out in local media outlets, South Tahoe Now, etc., for those notices on when you're able to comment and how you'll be able to stay involved and stay informed. There will also be additional opportunities to volunteer and to get involved out on the meadow for active stewardship, from everything from bank stabilization projects to litter cleanups, and hopefully some educational opportunities in the future as well. So stay tuned for that. And Adam, if you wanted to elaborate or anything.
I think you covered just about all of it. I just wanted to mention that we will send out an email to everybody that's here today with a link to the recording of this webinar, and there'll also be an opportunity on the Tahoe RCD website, a web tool to provide some more input on these alternatives. Another opportunity to share your thoughts before we get into that phase 2. And then, yeah, as Andrew mentioned, through that phase 2 environmental process, there'll be an opportunity to weigh in on the alternatives and on the issues that you want addressed in the environmental review in that scoping process. And then there'll also be multiple other opportunities as that goes along. There'll be a public review period for the draft environmental review where we'll release the full environmental document. People can read through that and provide comments. And then there'll be additional opportunities after that comment period, potentially before the TRPA board and other agencies that have to approve the project. So We're early in the planning process, lots of opportunities to get involved and to stay engaged through the environmental review and through the next stages of design.
And sorry, I just want to kind of build on that. Like Adam said, there will be multiple additional opportunities to comment. One thing that I have seen, there's been some vegetation management questions, and I have received offline additional questions about fuels planning. So Tahoe RCD is working on a forestry and fuels plan as a adjacent project to this to work on protecting adjacent properties and fire resiliency. So that is something we are working on. So, stay tuned for that. And then I want to jump on one more recreation question that Aaron Miller has asked. And the current trail system on the edge of Sierra Track, Tahoe Sierra neighborhood, there are some areas where it's in kind of bad shape. So when we move into evaluating alternatives and looking at implementation and, in between now and then, where we have opportunities to stop some erosion issues and to do some maintenance work that is on Tahoe RCD property, we are definitely looking at that and trying to figure out the best way to move forward with that. So that is a consideration that we were looking at both through this project and through just our regular maintenance and ownership of the property.
Thank you, Andrew. I do see one more question I'm hoping we can tackle, asking about whether or not the impacts and benefits to fisheries have been analyzed for the range of alternatives that I know we've been talking about. We're early on. This is preliminary. We have a phase 2 coming up. So Adam or Andrew, if you could tackle that for us.
Yeah, we haven't quantified or compared the benefits and impacts to fisheries for these alternatives. That's something that we looked at through the alternatives evaluation process, and that would be looked at in detail in that environmental review. But in general, one of the objectives that all of these alternatives are trying to achieve is to improve fisheries habitat, and we see that happening by increasing the riparian vegetation, getting a little more willow cover and shade that can cool off the water, which benefits the native fish species, and also by getting the kind of the right amount of flow in the water and installing some of those features, those enhancements like the grade control structures that can create a more natural system of riffles and pools, more diversity on the substrate of the river. When you look at it now, a lot of especially the Gully channel is very consistent and just kind of sandy bottom. So we expect all the alternatives to have benefits for fisheries. We haven't really quantified or compared those yet.
Thanks, Adam. All right, I think we're getting to the point where we will start to wrap up. Andrew did just give us a good run through of continued public involvement opportunities and next steps, and we will, as soon as we are able to get this webinar up on the project website, we will do that so that if you would like to go back and take another look at the presentation that Brent and Toby gave on the various alternatives, you can definitely do that and then send additional notes and comments and questions to the Johnson Meadow at Tahoe RCD email address, which would be a great way to share some additional feedback after you've had a chance to digest everything that we have discussed this evening. So with that, any final words from the project team before we wrap up?
I just wanted to say thank you, everybody, for being here. Your input and participation is really important to us. If at any point you have additional questions that have not been answered here, please send an email to the Johnson Meadow at TahoeRCD.org email address. That does go directly to me, and I can direct that question to the member of the team best equipped to give you a good answer. And if you're interested in ways to be involved beyond planning, please stay tuned for volunteer opportunities or reach out to the RCD and let us know you're interested. There's always stuff to do out there. The snow is starting to fly, and hopefully we get a lot of it this winter. But we will have the ability to get out there. We're still working on getting some of the old cattle fence out. There's always litter to clean up. And there's always bank stabilization work that needs to get done, particularly in the fall. We've done some willow staking that has actually taken really well. And that is some of the things in the future. And we're also looking to expand education opportunities out there for local school groups and local volunteer groups as well. So, stay tuned, sign up for the email list, watch out for scoping notices that will come out once we initiate phase 2, and then following notices to allow for follow-up public engagement and public involvement once we start getting into the draft environmental document process. So there will be lots of ways to get involved. Lots of ways to influence the process and learn about the process. And if at any point, even outside of one of those formal comment periods, you have a question, please do not hesitate to reach out via the Johnson Meadow email address or the TahoeRCD.org website. And we will get back to you as soon as we can. I think we've answered all of the questions that we can. There is one question here that I think would be worth following up with Patrick Riesenthal that I will follow up directly, and with Marlon Charnot as well. So if your question wasn't answered tonight, I'll follow up directly with you and make sure we get you that answer. But thanks so much for spending your evening with us, and we hope to see you at future events, hopefully maybe one day in person again.
All right, thanks all. Thanks again for your participation tonight.